In the main graph, we observe a batch process where different product grades are produced, such as alpha, beta, and gamma. We will focus on the production of alpha. We also have added the associated concentration profile, cooling water, and temperature tags. What we want to do is to find a period of ideal alpha production and compare it to another period where the obtained results were not optimal, to study and identify the differences. To achieve this, we first go to the search menu. We start a new value-based search. Our initial objective is to find all the periods where the batch process is producing product grade alpha. Therefore, the product must equal to alpha. We conduct the search and find our results, displayed as blue bars in the context chart. Now, to identify what constitutes an ideal profile and what does not, we need to determine our criteria. In this case, it will be the maximum concentration value obtained. A higher final concentration indicates a higher quality batch. Therefore, we will add a calculation to each of these results, specifically the maximum final concentration. We take the concentration variable and calculate its maximum value. As a side note, notice that we can add up to 30 calculations. Once completed, we can sort our results by calculation by clicking into the three dots menu. The list will display the batch with the highest final concentration at the top. We can define this batch as the base layer to display it on the main screen. If we sort the results in reverse order, we will find the batch with the worst outcome at the top. We can add this as a layer, overlaying it on top of our ideal profile. This way, we can visually compare the two concentration profiles, seeing that it is indeed lower and possibly due to this pressure drop. This is only a visual comparison. If we want to do it quantitatively, we can open the Compare Layers table at the top where we see our layers. We can rename the layers in this table. For example, we call the base layer high concentration and the second layer low concentration. We can then evaluate the statistical parameter we want. In this case, we are assessing the evolution of the variables. We see that the low concentration layer period has a similar evolution for all variables except for pressure, where it differs slightly from the base layer. This pressure drop could be causing the difference in the final concentration. We can also compare other parameters besides evolution. To change the parameter that we see, we go to the Settings menu and select a different statistical parameter, such as average.